Hi students, in this video we're going to look at an example of a bond issued at a premium. Now we are using the effective interest method, which is required by IFRS, which is the method that almost all companies who do issue a bond would be using. Now I've got a lot here on the screen already for you. We'll go over this slowly and make sure that you understand where these numbers are coming from. And then we'll develop this solution and we'll do the first 2 or 3 journal entries and you'll see how it's going to work. So I'll just remind you that a bond issued at a premium means that the debtor is offering a higher interest rate than the market requires. Investors will bid up the price of that bond until they're at their required rate of return for that bond. So the debtor is going to get more than face value for a bond that's issued at a premium. So here's our issue date, June 30, year 5. We're just going to use $1 million bond just so that we don't have too many zeros going on. The coupon rate is 7%. Now, remember, if the bond pays interest every 6 months, 7% is an annual rate. We have to divide that by 2, which equals 3.5% to get the payment that happens every 6 months. The term is 20 years, and this bond pays interest 2 times a year. So there will be 40 interest payments before it's repaid. The market rate is 6.1%. So again, that's a yearly rate. We have to divide that by 2 to get the 6-month rate. Now I'm going to use a financial calculator to determine the selling price of this bond. Now in this course, you are not required to calculate the selling price with a financial calculator or Excel. If you're going on in accounting, it would be a great idea to learn this skill set early. Even if you don't invest in a financial calculator, at least try this in Excel using the PV function or present value function in Excel, and you will get exactly to the penny the same issue price that I've calculated here. So here are the calculator inputs. We would key in $1 million. Now, of course, on a calculator, you don't put in your zeros, so I didn't here. $1 million is future value. 35,000 is payment. There are 40 payments. So 40 is N is number of payments, and 3.05 is interest. The only real difference between the financial calculator and Excel is the financial calculator, when I key in 3.05, it assumes this is a percent. In Excel, you'll need to put in 3.05 and the percent sign. And this gives us a present value right here. So 1103, 180, 85. Now, in this course, if you need to do a bond question and it is issued at a discount or premium, you're going to be given a bond quote. And I want you to keep in mind that the quote is actually a percent. Now, strangely enough, they don't use the percent sign on the quote, but it actually is a percent. Now, bonds do sell in the marketplace. So if this bond has been around, let's say for 15 years, somebody might put their bond up for sale and it has 5 years left. And if you were to look at some of the financial papers or online, you would see that the bond comes with a quote. So the bond actually does have an interest rate, a price quote in the financial markets, and that's how investors know what they have to pay for the bond. So the quote is 110.318085. So essentially this. So if you take your calculator and you go $1 million times 110.318085 and hit the percent key, you're going to get the issue price of the bond. So let's first develop our bond amortization table. I've copied in the carrying amount here. Now the payment is $35,000, and that's going to be, let's see here, the payment is going to be $35,000 every time. The payment doesn't change. Under the effective interest method, it's the interest expense for the period that changes each time. So interest is going to be the carrying amount, and we're going to multiply that by the interest rate. So in this case, remember, this is the 6-month rate, not the 1-year rate. So we're going to go multiply this by 3.05%. Notice that's the market rate. It's not the coupon rate. We already know the payment's $35,000. The interest expense is the carrying amount times the market rate. So there's our interest expense. Now the premium that's amortized this period is the difference between what you paid in cash and your interest expense. So we're going to take the payment and we're going to subtract interest expense, and that's the premium that's amortized. Now, do we take this 1103,180 and make it bigger, or do we make it smaller? So do we add in the 1352, or we deduct it? Well, our goal is after 40 interest periods to pay back investors $1 million. So this number here has to come down, not up. Over 40 periods, it's going to drop to $1 million. So I'm going to take this number here, the carrying amount, and I'm going to subtract the premium that's amortized. So we're down to 1101,827. Now notice that as the carrying amount goes down, carrying amount times 3.05% is going to get lower and lower and lower. This is the effective interest method. Our interest is not 33,647 every time. It changes and it gets lower and lower and lower as the bond gets closer to the $1 million repayment amount. So I have to do this. So there's my $35,000 payment. To do this on Excel, I need to stabilize that payment, and then I'm going to drag this down one more. So this 33,605 is simply 1101,827 times 3.05%, and there's our number. So now that I have a formula in Excel, this is all on a formula, I can take this line and I need to make 38 more payments, right? So again, what I do is I don't want to count 38. I'm just going to drop it down a long way. And how do I know I got there? Well, look here. This is $999,999.99. That means basically we're a penny off our $1 million from rounding. So that's our whole interest table. And I didn't fill in the date column, but what you can see is the date column would be, June 30, December 31 the next year, June 30, December 31, and so on. So that wasn't too bad, right? We can do an amortization table for the whole bond on Excel, and we know that it ends actually when we owe $1 million. So I can guarantee you that this is 40 interest payments. Now, for this video, I want to show you how to do the journal entries for just the first couple of interest payments, because what I've got here is a bond that pays June 30 and December 31. So we don't need to do an interest accrual on December 31, right? The payment is December 31. There's another video in this series showing how to accrue interest on a bond when the payment is not on December 31. So just to keep things simple, what I'm going to do here is I'm going to get rid of all this so that we can look at some journal entries. So let's look at our journal entries. Well, the first entry is the issue date of the bond. So June 30, year 5. It's our first entry. Now, I'm going to mess up this table a bit because I need bigger spaces for the account title column and the debit credit column. Okay, so let's do our first journal entry to issue the bond. Now we're using the net method, and I want to remind you that the net method is a lot easier than using an account called premium on bond payable. It's easier and you're less likely to make a mistake. So everything in your module, when you read that module, is based on the net method. So I want you to use that in your assignments and on your exam. So we're going to start with cash, because we got cash and we have a credit to bonds payable, and the amount is our issue price. Let's make sure this fits. So there it is. Now, what we can do most times in school is we can often round this off to the nearest dollar, and that's just to save us writing all the cents all the time. So I'm going to do that here. I'm going to say, okay, we're allowed to round this off to the nearest dollar, and there we go. So along comes December 31, and this is our first interest payment. The great thing about doing a bond amortization table is that we've already got all our numbers. All we need to do is use these numbers in our journal entry. And remember, debits have to equal credits. Note that these two numbers added up to the $35,000 payment. So our first debit is interest expense, and the amount is right here. Now, I want you to notice that the bond carrying amount is going down. How do we reduce a liability? We reduce a liability with a debit. So we have to debit bonds payable, and that's going to decrease the carrying value of the bond. So here's my bonds payable, debit. And of course, the coupon payment itself is cash. So here's the coupon payment right there, $35,000. So that's our entry. That's it. Now, could you do June 30, year 6 on your own? June 30, year 6 is just going to be the same account titles. And let's look at what doesn't change. The amount of the payment is constant at $35,000, but the interest expense and the premium that we amortize change every interest date. So if you have a bond amortization table, it's super easy to do your journal entries because, I'll show you how easy this is. Here's June 30, and this is now year 6. It's the same account titles every time. And it's the same $35,000 payment of cash every time. So where do the other numbers come from? Well, they come from your amortization table here and here. So our interest expense this time is here, and the decrease to the carrying value of the bond is here, and there's our second journal entry for interest. So if you have this table done for 40 periods or 20 years of the bond, then you could do all the journal entries for 20 years of the bond just with the same account titles every time, the same payment every time. There we go, round it off. Okay, so it just repeats itself again and again and again. The real complication for you at this level of accounting comes in when the interest payment is not on December 31 at the end of the year. And I have another video for you explaining how to split up the interest between the months before December 31 and the months after December 31. So that's all for today.